Good morning, students. So we discussed in the last class. So what is the potentiometer? And potentiometer used to determine internal resistance of the given two cells. Okay, given two cells. So now today discuss the another topic. So that is the potentiometer used to determine internal resistance small r. Internal resistance small r by using the potentiometer. Okay. Determine internal resistance by using potentiometer. Okay, now see the first of all circuit diagram. Okay, so potentiometer. So what is the principle of the potentiometer? So the potentiometer is based on the principle that which having the uniform cross sectional area and so the current passing through is the steady current. So the steady current is passing through the wire and uniform cross sectional area. So the potential difference across any portion on the wire, the potential difference across any 2 points on the wire is directly proportional to the length of the wire, its length. So that we can write in mathematical form. So E is directly proportional L. Okay. So this is called as a based on the principle. So is the working of the potentiometer. So what is the potentiometer? So the steady current is flowing through the wire. Okay, steady current is flowing through the wire and so the uniform cross sectional area is consisting. And also, so the potential difference across any portion on the wire, any 2 points on the wire is directly proportional to its length, that is called as the L. Okay, got it. Now here we can write mathematical form. E is EMF or voltage. E is directly proportional L. Okay. So E is equal to pi L is also we can write pi is called as a gradient. Pi is called as a electrical gradient. Now here in the circuit diagram. So before last topic to find out the two cells is given. So the comparing of the two cells E1, E2 is taken, but here only one cell is taken in the circuit. Observe here. Okay. Now here this is called as a battery and this is called as a rheostat. And so plug key. And so K2. That is the second key. And E is called as a cell. EMF of cell is taken E. And RB is called as a resistance box. RB is called resistance box. So G is called galvanometer. Galvanometer. So last to attach the jockey. Okay. So now here B is called as a battery and the steady current is flow through the wire or potentiometer wire by using the rheostat. RH means rheostat. So rheostat use or purpose, so that means the steady current is flowing through the wire. 2 amperes 2 amperes, 3 amperes 3 amperes. That particular current is passing through the wire. Okay, got it. So now here RB is called as a resistance box. Resistance box. Nirodhala pette ani pilustaru. Resistance box. So the number of the resistance introduced or including in a resistance box. So that is called as a 1000 ohms. Okay, that is a 100 ohms. Whatever may be taken, that is called as a resistance box. 1 ohm, 2 ohms, 5 ohms, 10 ohms, 50 ohms, 100 ohms. Okay, 200 ohms, 500 ohms, 1000 ohms. Okay, already, so that is called as a, is taken a resistance box. K1, K2 are plug keys. Plug keys, that is called as a on off switch, just like buttons. And so E is called as a cell. EMF of cell is taken E. And so the galvanometer. So the galvanometer is to find out the so the smallest current is to find out to measure the smallest current is in the circuit. The jockey is used to the sharp edge device. Sharp edge device. Okay, so the sharp edge is moving on the wire, potentiometer wire. Okay. So first of all, here see that. So the battery is a negative is connected to the A. Okay. So now here that is the resistance box and so here the negative is connected to connected to the galvanometer. Okay, galvanometer and through the jockeys also. N1, N2 are the position of the length. Position of the length. So A, N1 is the first position of the length. And A, N2 is the second position of the length. This is only single wire. Okay, ఒకసారి N1 వద్ద సూచిస్తున్నాను, ఇంకొకసారి N2 వద్ద సూచిస్తున్నాను. Okay. Now, so first of all, fundamental arrangement of the circuit. Okay. So first of all, so the battery is on. So some current is passing through the circuit. So the steady current is flowing through the circuit by using the rheostat. So the rheostat adjustment. The rheostat adjustment that means so the steady current is flowing through the potentiometer wire. Okay. So that is the totally experiment is completed. Throughout total experiment. Okay, it is does not disturb of the rheostat and battery. That means so the total experiment is running through 1 ampere or 2 amperes or 3 amperes, whatever may be taken. That is the steady current. Entire through of experiment is completed. Okay, so the don't disturb of the rheostat. Okay, good. So that is called as a primary adjustment. Primary adjustment. Now, so next one, key 1 is K1 is closed. Okay, the current is passing through the circuit. Okay, so now here see that. So first of all, so the K2 key is open. K2 key is open. K2 key is open. That means only E cell is including insert through the circuit. Okay, there is a resistance box is called resistance box is a just like switch off position లేదు అనుకోవచ్చు ఓకేనా సో that is only is available in the circuit okay so now here K2 is key is open only is introduced in the circuit and so the jockey is moving on the potentiometer wire. The potentiometer wire is attached to the wooden box with the scale. Okay, got it. So this is called as a total wire, potentiometer wire. So the potentiometer wire is attached to the wooden box with the scale. Okay, got it. So the galvanometer is the jockey. So the jockey is moving on a potentiometer wire. Till. So the galvanometer deflection is 0. Galvanometer deflection to reach the 0 up to. So the jockey is moving on a potentiometer wire. Okay. So the jockey is moving on a potentiometer wire. The galvanometer deflections to reach the 0 position. There is a null point to reach. At a particular time, the length L1 is noted. That is called as a N1 is taken from the circuit. Okay. So that is called as a E is directly proportional length L1 is taken or AN. That means AN. Okay, AN1. Okay, so that means the jockey is moving on potentiometer wire, not a stress, only so touching on the wire. So on the wire until the galvanometer show the 0 deflection. అంటే అది 0 అపవర్తనం వచ్చేంత వరకు మనం జరుపుకుంటూ వెళ్ళాలి ఓకేనా అంటే the deflection to reach the 0 so the stop then stop so to find out the length. Okay, so we can write the E is directly proportional L1 or L. E is directly proportional L. Got it? Now is taken another step that is called as a K2 key is closed. K2 key is closed. K2 key is closed, introducing or including the resistance box through the circuit. Okay. So the K2 is before, the K2 key is closed before resistance box. Okay, the smallest alamunde. So that means so some resistance is removed from the circuit. Some resistance is removed from the circuit, or that resistance key is removed. So the key is removed, that is inserted to the circuit. That is inserted to the circuit. So that means here this is called as a resistance box. So the number of resistors are included in the circuit. Okay, number of resistors. So that means here, so that is called as a 1 ohm, 5 ohms, 10 ohms, 50 ohms, 100 ohms. So the plug key is removed, okay, from the circuit, from the resistance box. The plug key is removed from the resistance box. That particular resistance is introduced or inserting through a circuit. Got it? Very important point. So here the plug key is inserted, so the current is passing. Here the plug key is removed. That particular resistance is introduced to circuit. That means the suitable resistance, the plug key is removed, introducing of the circuit, including of the circuit. Got it? So now here also the jockey is moving on the circuit, on the potentiometer wire until the galvanometer show the deflection is 0 or null deflection. Okay, so that means the jockey is moving, the plug key is inserted and the resistance box, suitable resistance introduced in the circuit on a resistance box. Now the jockey is moving on a potentiometer wire till the galvanometer show the deflection is 0 or null deflection. At that particular time situation, to find out the length L2, that is called as A and 2. So we can write the thermal potential difference. E is directly proportional N2, equation 2. Okay, so that is also called as AN2. Okay, equation 2, equation 1. So this is called as a terminal potential difference. V is called as a, not E is here to write, because we have taken terminal potential. Terminal potential, a terminal potential difference. V is directly proportional L2. Okay, so now divided in equation 1 with respect to equation 2. So E by V is equal L1 by L2. L1 by L2. Got it? Okay. So this is called as a equation 3rd. Right. So E by V is equal L1 by L2. We can write. Now, so E is equal to I R plus R. We can write in a last class, some problem are used. Okay, this equation E is equal to I R plus R. According to Ohm's law, V is equal IR. V is equal IR. These two equations are dividing. Okay, dividing. E by V is equal I R plus R by I into R. I cancel. Okay, so remaining equation we get E by V is equal to R plus R by capital R. Okay, so this is called as a equation 3rd. Okay, equation 4. So E by V is equal L1 by L2 from the circuit. But in a formula, E by V is equal R plus R by capital R. R plus R by capital R. So these two equations are comparing. Equation 3 and 4, we get R plus R by R is equal to L1 by L2. L1 by L2. Okay, R by R. So dividing with respect to R. 1 by R by R. R by R cancel. 1 is taken. Plus R by R we can write. That is equal L1 by L2. So R by R is equal to L1 by L2 minus 1 we can write. So small r is equal to L1 by L2 minus 1 into R we can write. So this is called as A. To find out the internal resistance. To find out the internal resistance by using the potentiometer wire. Okay. So R is called as a internal resistance. Okay. Capital R is called as a external resistance. External resistance is given to the resistance box. Already we know that is called as a 5 ohms, 6 ohms or 10 ohms. So whatever may be, that is called as a suitable resistance is introducing the circuit. Okay, got it. So that is means R is means external resistance. L1 is the length. So that is called as the primary length. L1 is equal, so something 30 centimeters or 35 centimeters is taken. L2 is equal to 60 or 65 centimeters is taken. So to find out the internal resistance, that is called as a small r by using the potentiometer wire. Okay, potentiometer principle. Okay, got it. Right. So next one problem. In a potentiometer arrangement, a cell of EMF 1.25 volts gives a balance pointer at 35 centimeters length of the wire. If this cell is replaced by another cell, and the balance point shift 63.0 centimeters. What is the EMF of the second cell? Okay. So now given a potentiometer arrangement, a cell of EMF given cell of EMF that is equal E is equal 1.25 volts supply. Okay, and given a balance point to find out the balancing point already. So the galvanometer, that is means the jockey is moved on a potentiometer wire till the galvanometer show the deflection is 0. That is called as the length L1 is measured. So that is called the 35 centimeters of the length of the wire. So that is L1 is equal to 35 centimeters. Okay. If the cell is replaced by another cell, okay, and so the balancing point is shifted 35 centimeters is find out the first of all. So now here that is nothing but the cell is replaced. Okay, so that is means so if the cell is replaced by another cell, okay, so and the balancing point is shifted, so 63.0 centimeters. So what is the EMF of the second cell? So that is the point is L2 is equal 63.0 centimeters. Okay, so E1 is cell is first of all introduced in the circuit. So that is 1.25 volts, and so L1 is the length is measured 35 centimeters, and so L2 is equal 63 centimeters when that is the cell is replaced. Okay, and that means so the second EMF is to find out. So that means, okay, so the comparing of the EMF of the two cells by using the potentiometer formula, based on potentiometer formula. So that is the E1 by E2 is equal to L1 by L2. Okay, E1 by E2 is equal L1 by L2. So E1 by E2 means E1 by E2 is equal L1. L1 means 35 centimeters. So 35.0 centimeters by E2 is equal, that is means L1. L2 is equal 63.0 centimeters. Okay, so E1 already know that 1.25 volts. Okay, so cross multiplication, E2 is equal 1.25 into 63 by 35. So E2 is equal 2.25 volts we get. Okay, so the simplification we get the EMF of second cell. EMF of second cell is 2.25 volts. Okay, got it. By using the comparing of the EMF of the two cells, so E1 by E2 is equal to L1 by L2. But given the E1 and L1 and L2 to find out the E2 of the second cell, that is called as a 2.25 volts.